Dear students, in this video lecture we are going to discuss about probability and relation between conditional probability and unconditional probability. In the last video we discussed about basic definitions of probability. Let us start the session. Probability we defined as degree of belief, where we need this particular probability theory, especially for uncertain reasoning, where we can't have any clear and fast rules. We call it as uncertain reasoning. If toothache exists, then it is due to cavity. This is what the definition we gave. Then later we defined it is not only due to cavity, it can be by anything else also. Many things we discussed. Now we'll discuss more about probability. Patient went to dentist, not for any dental problem, not for any toothache. Remember, for general checkup. Now, doctor identified patient is having cavity for that particular patient. For the patient who all went for general checkup, in general, 20% of the patient is having cavity, which means if a patient is going to a doctor, especially dentist, for a general checkup, not for any toothache, okay? Because later I am going to discuss about toothache. General checkup, then he is having a cavity is for 20%. We represent as probability of cavity is 0.2. That is called 20%. Now, patient took appointment with dentist due to toothache. Remember, here it is due to general condition. Generally he went. Now it is due to toothache. Now, patient having cavity given condition toothache. Okay, remember, it is called condition probability we discussed. Condition toothache as 60%, which means probability of cavity given condition toothache is 60%, 0.6. Come on, try to differentiate yourself. What is this 0.2 about cavity? What is this 0.6 about cavity given that it is toothache? I am going to give a general example. Just you go to a mall, okay? You go to a mall or you go to a market. Generally take 100 people, okay? Generally take 100 people. 5 people may be engineering student. Probability of engineering student is 5 people. Where generally, that is called general in a market or in a mall. My question is now different. Go to a engineering college. Take 100 people. What is the probability of engineer? Obviously near to 100. In case if some college is having MBA or something, maybe less. But probability definitely it is more than 80%. Now you should not ask me the question. Sir, previously the probability of engineer is lesser. Now it is more. Means where it is in engineering college, probability is more. In general, probability is less. In general, cavity is less. For a toothache people, cavity is more. I hope you got it. Yes. So 0.2 for probability of cavity, 0.6 for probability of cavity given toothache. Now, probability of cavity given toothache is 0.6. It is called conditional probability. Sir, I don't want conditional probability, sir. Can you modify this statement as an unconditional probability? Yes. Conditional probability can be defined in terms of unconditional probability. How? Using product rule. Using product rule. Probability of cavity given toothache equal to probability of patient having both cavity and toothache. That's called cavity and toothache given that for probability of toothache is exist, provided probability of toothache must exist, that is called greater than 0. Okay, so using this particular property, see left hand side condition, to right hand side just and, that is called conjunction. So this is no condition. In above equation, LHS left hand side is conditional probability, RHS is unconditional probability. So we relate in this particular video session conditional probability with unconditional probability. Now we are going to use the product rule I told. Who is left hand side? Conditional probability. Who is right hand side? No given symbol. Okay. Unconditional probability. Now I made it. Just take this denominator, bring here. Okay. I got this term. Okay. I got this term. Now this is called product rule. What is product rule? Probability of cavity and toothache is true provided equal to probability of cavity given toothache with probability of toothache. Now let us generalize. Probability of A given B equal to probability of A and B divided by probability of B. If you just cross multiply, I got this particular statement called product rule. Now what I told for cavity and toothache, I am going to do generally. For A and B to be true, LHS is true, then RHS has to be true. Okay. For A and B to be true, then we need B to be true. Okay. Always I told that probability of toothache should be true. B to be true. Also, given B, A should be true. Okay. Now this is called product rule. We may need in many places. Generally they will say, try to define probability with an example. You can use this. Now, let us see probability assertion. Assertion means statement of fact, telling the reality. Okay, statement of fact. I am going to define a domain. What do you mean by domain? Set of possible values it can consider, it can take. Don't get confused about domain. I will give an example, you will come to know. Age domain. What do you mean by age domain? There are some age group of kids less than 10 age. There are some age group called a teen. What do you mean by teen? 11, 12 won't come under teen. 13, 14, 15, 16, 17, 19 up to there called teenage. Next, adult. Those who crossed 20 is called adult. 26 also okay, general. So there are three different group: kid, teen, adult. This is called age domain. Age domain. Now let us take a teen is going to a dentist for checkup. Very long back I told cavity means it should give no toothache. Maybe it will give toothache, but for youngsters I told in the last video session, for youngsters there may not be a toothache. Okay, because they may be youngster. Now I am defining in terms of a domain called teen. Now probability of cavity is 0.1, very less. Why? Given no toothache and teen. Okay, if there is a teen, there may be not be a toothache, but cavity exists. This is called conditional probability with some statement. Now let us have the another domain called the weather domain. Previously I discussed age domain. Now it is weather domain. Different weather conditions: sunny, rain, cloudy, snow. I don't think so all will exist in the same time, but all may exist in the same place in different conditions. Let us see. For a given duration, let us take Delhi, because Delhi is a place where you can have more sunny also, 45 degree it will go. Same night time more snow also will be there. Snow is not there, but sometime it may happen. Very rarely. In winter you may get good snow also. So in Delhi, weather condition, especially in March, 60% is sunny, just 10% is rain, nearly 30%, we say 29%, 0.29 is cloudy, and just 1% is snow. So if you add the probability, it should be 1. We discussed 0.6 plus 0.1 plus 0.29 plus 0.01. If you add all, it is nothing but 1. In general. Sir, now what is probability of weather? What is probability of weather? It includes all weather domain: sunny, rain, cloudy, snow. It may vary. In hill station, cloudy may be more. In Himalayas, snow may be more. In Ladakh, snow may be more. Sunny is less, rain is less. So in general, sir, it is called a weather. Now, probability distribution, this is distributed, you see, 0.6, 0.1, 0.29, 0.01, distribution. Probability of distribution of weather. Whenever I use probability of distribution, a group I am going to tell for the weather distribution, we represent as bold letter P. Okay, is 0.6, 0.1, 0.29, 0.01. Sir, how I know who is he, sir? First see the weather domain. Sunny, 0.6. Rain, 0.1. Cloudy, 0.29. Like that you should know. So this is not weather, it is weather distribution called probability of distribution. Now, bold letter represents probability distribution. Let us have joint probability distribution. Sir, you told weather condition. Is it related to cavity? Maybe. How come, sir, weather is related to cavity? Sir, heavy summer, sir. Everybody will start take ice cream. Possibilities there? Yes. Start taking ice cream. If you take ice cream, your sensitive tooth, cavity may give pain. You might have gone to doctor for checkup. So, I am just relating. That's called intelligence. I am just relating cavity with weather. One such discussion is, in a sunny day, patient went to dentist and identified for cavity. So listen, sunny day, cavity is existing. How to represent? Probability of sunny, weather equal to sunny, and cavity exists, cavity is true, equal to probability of sunny given cavity. Recall product rule. Okay, left hand side is unconditional probability, right hand side is conditional probability, and probability of cavity is true. This is called probability of cavity. Instead of weather, I told W. Instead of cavity, I am saying C. Probability of W and C equal to probability of W given C into probability of C. C is nothing but cavity. Sir, there is some patient went to a doctor, especially in sunny day, but identified no cavity. How to mention? Same statement. Instead of cavity is true, I can say false. Instead of C, I can say negation C. Come on, this is the statement I am going to modify. Now, sir, sunny, cavity exists, cavity doesn't exist. Similarly, cloudy, cavity exists, cavity doesn't exist. Next, rain, cavity exists, cavity doesn't exist. Next, snow, cavity exists, cavity doesn't exist. Come on, totally 4 different weather, 2 possibility, 4 into 2, 8. Same for all weather I can write. It is I left you to write such statement. Okay, instead of sunny you put rain, you can put cloudy, you can put snow. Cavity, no cavity. Okay, you can do. You will get 8 general distribution. I am linking, jointing probability distribution. Please remember this particular idea. Sir, can I link one more domain? Let us see. I am going to combine probability of different variables. Cavity, just now I discussed. Weather, just now I discussed. Toothache also I am going to bring into picture. Now tell me, cavity 2 possibility. Cavity, no cavity. Toothache 2 possibility. Toothache, no toothache. Weather 4 possibility. Sunny, rain, cloudy, snow. Now if I combine, probability distribution for above 3 variables is 2 for cavity. Cavity, no cavity. Toothache, no toothache. And 4 different weather condition. 2 into 2 into 4 is 16 possible equation. Previously 8 equation. Now 16 possible equation. We call it as possible world. What do you mean by possible world? Which means each variable, cavity, toothache, weather, can take all possible option. A possible world is defined as an assignment of value. This value is there, you see, cavity, toothache, whether I am assigning some value. Toothache, no toothache. rain, winter, sunny, cloudy, snow. Assignment of value for all of the random variables, cavity, toothache, whether is called random variables under consideration. What and all you considered for that variable, if you assign all possible value, it is called possible world. Now I joined three different distributions. We call it as full joint probability distribution, not just one. If you take just weather probability distribution, I just took toothache and weather joint distribution, cavity, toothache and weather full joint probability distribution. Okay, it is representation of probability of all 16 possible world. How that 16 possible I brought, remember pa? P probability I made capital P for your reference. Probability distribution of cavity, toothache and weather. Okay, with I would like to conclude this particular video session. Thank you.